In number 17, they ask for the point estimate. That's a simple way of asking what the average is for the confidence interval. So I'm just taking the average of the lower and upper bound. For 18, they're talking about the 10% condition. Why do we need to check it? Because when we're sampling without replacement, there is not, the events are not independent. So by checking the 10% condition, we're saying that they're so close to independent, it doesn't matter. Number 19 is asking you to interpret the expected value of negative 0.95. So that just means on average over the long run, how much that they're going to lose per raffle ticket. 20 is asking about power. They want the highest power. Well, that's going to be the greatest difference between the true value and the alternative. So in this case, the alternative is less than 10. So I'm not going to choose C, D, or E. None of those are less than 10. So the greatest power would be 8. Basically, it's a little bit easier to detect the difference between 8 and 10 than it is 9 and 10. 21, we want to know which residual plot shows that a linear model would be appropriate. We want random scatter, no pattern. A and B have pattern, D and E get into kind of this cone shape. So not consistent variability in the residual plot, which is an issue. 22 is asking you to really interpret the confidence interval. So really what they're giving you is the interpretation of the confidence level. If we do all these random samples, about 95% of the confidence intervals are going to capture the parameter, in this case, the true mean number of hours of sleep per day. You'll notice the other choices, it's saying 95% of students. That's not what a confidence interval interpretation looks like. All right, 23 is just going through a two-way table and talking about some different probabilities. So if a person owns a car, so that would be 60 people, he or she is more likely to live elsewhere in the city than to live downtown. Elsewhere in the city, 15 out of 60, that's 25%. Downtown would be 10 out of 60, or about 16, 17%. So yes, that's true. 24, they're setting up a confidence interval for a proportion. So the sample proportion, 23%. That's your statistic, so A, B, and C are out. The only difference between D and E is the critical value. It's a proportion, so I'm using the normal distribution. Inverse norm of 0.025 gives me that critical value of 1.96. So correct answer is D. 25. Travel time is normally distributed with this mean and standard deviation. If they leave at 8:25, what's the probability they get there later than 9? So it'll take them more than 35 minutes. Just getting a z-score and then doing normal CDF from 1 to infinity, it's going to be about 16% of the time that they would be late. Question 26 is asking about sample size, but without doing the actual calculation. So the margin of error is 2.5%. So at that point, I was able to get rid of choice C and E based on that. And they're saying, assuming that at least 79% of adults use the internet. So we're assuming that to be true. So A, B, and C are out. At that point, I know the answer is D. Just so you see where that critical value comes from, it's inverse norm of 0.01 to get that critical value. 27, what kind of test should we use? We're talking about how long the batteries last. So we're talking about number of hours. We have units. This is quantitative, so D and E are out. We want to know, does A last longer? So the two-sided test would be out. So I'm down to A and B. They're not paired. It's just one battery versus another battery, and they're independent groups. So this would be a two sample t-test, not paired. 28 is kind of tricky. If you got this wrong, you probably put choice A. because the two-tailed test was 44%. I cut that in half, I get 22%. The reason it's choice D is you could have a lower tail test, which there would be 22% of the area here, or an upper tail test, which would be the complement of that, or 78% of the area would be here. So that's how to get choice D. 29. Basically, you're going to run through the test, doing the test statistic, and then using TCDF if you're going to do this out by hand. Or what you can do is run stat test to sample t-test, plug in the data. I plugged in fertilizer B for group 1. It's not going to matter. Not equal to, we want to see if there's a difference. We're not pooling. And if I calculate, I can see the p-value 0.016. 0.016. So that's between 1 and 5%. So we do have statistical evidence. Question 30 is again talking about what type of test should we do. This is a two-way table. It's categorical. So choice A and C are out because that would be quantitative. Two sample z-test, we have more than, we don't have two samples. We have one sample, a random sample. So that doesn't make any sense. Goodness of fit is one variable, one sample. Test of independence is one sample, two variables. We want to see if there's a relationship, so an association. So we're talking choice E. Question 31. They did a whole bunch of randomized experiments, and they wanted to see if the drug had no effect whatsoever, which of the following results would be anticipated. Well, if the drug didn't have an effect, we'd expect to fail to reject the null quite a bit of time. There's an equal number of experiments showing positive and negative results. That makes sense because otherwise, if they're all in one direction, we'd think that the drug is effective. And when 95% confidence intervals are created, we're going to capture 0, meaning there was no difference a very large proportion of the time.